Recall that today we talked about how to do a verification in trig. We talked about how a verification means that you are trying to prove that the left side and the right side of an equation are equal. You don't know yet if they are true, therefore you cannot move terms from one side to another. And that is a super duper important concept to remember as we're working through our lesson today. Some tips that we talked about is that we always want to rewrite the more complicated side of the equation first. It's a lot easier to take something that is messy and clean it up than it is to take something that has already been simplified and try to make it more complicated. Once you have figured out the harder side of the equation, then the side that you are not changing is your goal. You are going to leave it alone and try to make the other side match it. Different strategies, we need to know those identifications, or all of those identities. Sometimes it's helpful to write things in terms of sine and cosine. Don't be afraid to try to factor, FOIL, distribute, combine fractions, etc. And if you see something in your problem that involves a 1 plus sine x, 1 minus sine x, and so forth, try multiplying the top and bottom by a conjugate. What this does is this allows us to use those Pythagorean identities once we simplify. Today in class we took a look at the first two. We saw how when you are working with the first problem on the left, that the right side of the equation was more complicated, and we went ahead and we simplified the right side until we got a match. Once the left side and the right side are equal, we have done our job. In problem 2, we talked about how there are various ways to complete this problem as well, and took a look at one strategy where we converted everything to sine and cosine first, and another strategy where we replaced the 1 plus cotangent squared of x with cosecant squared of x right away. Today we are going to go through the remaining 3 problems together. For this problem, I think most of us would agree that the left side of the problem is more complicated because it is a fraction. What we are going to do is we are going to split the numerator. Now when we split the numerator, we will have tangent of x divided by sine of x, cosine of x, minus cotangent of x over sine of x, cosine of x. And again, everything on that right-hand side we are not going to touch. At this point, we are going to think about how we can represent tangent and cotangent in terms of sine and cosine. So I know that my tangent is equal to sine over cosine, so I can write this as sine of x over cosine of x, and then continue that with the sine of x, cosine of x that were already written in the denominator. Then I know that cotangent can be written as cosine of x over sine of x, and then again continue with the sine of x, cosine of x that were already in my denominator. At this point, I can see how my sine of x's cancel and my cosine of x's cancel, and I'm left with 1 over cosine squared x minus 1 over sine squared x. And typically as we're going through the process, you want to look at the right-hand side and see if you're getting close. And I am getting close because my right-hand side has 2 squared terms being subtracted. I currently have 2 squared terms being subtracted, except they're in the bottom of the fraction. However, I can rewrite cosine as a secant, and I have secant squared of x minus cosecant squared of x, and I have a match. And remember, you gotta always finish with a smiley face. Alright, let's try the next problem. In this problem, we want to try the strategy of multiplying by a conjugate. And when we multiply by a conjugate is to allow us to have that Pythagorean identity help us out here. It doesn't really matter which side we start with. I'm just going to start with the left-hand side. And the conjugate would be 1 plus sine x. When you're trying to figure out what to multiply by with, you want to think about whichever binomial would FOIL with the 1 minus sine x to give you a difference of 2 squares. So at this point, I'm going to have 1 plus sine of x multiplied with cosine of x all over 1 minus sine of x squared. And I don't want to factor this. If I factor it out, I'll get right back to where I started. That won't do me any good. Instead, I'm going to recognize that 1 minus sine squared x, I can replace that with a Pythagorean identity. So my numerator is going to stay the same, 1 plus sine x times cosine of x all over when we're trying to figure out how to rearrange this off to the side, we can recall the original formula. So the original formula is sine squared x plus cosine squared x equals 1. And in this problem, I happen to have 1 minus sine squared x. So if I were to minus the sine squared to the other side, then that would be equal to cosine squared x. So I can now replace this denominator with cosine squared x. And at this point, this cosine and one of those cosines cancels, and I'm left with 1 plus sine of x over cosine of x, which is what I'm trying to match. And there's our next smiley face. All right, final problem. Now, in this problem here, nothing really looks that nice at all. Nothing really. So there are a couple different ways that we can do this problem, and some ways are definitely harder than others. What I'm going to do for this problem is I'm going to start on the left, and I'm going to take all of my secants and tangents and rewrite them in terms of sines and cosines. So what that will give me is 1 divided by cosine of x plus sine of x over cosine of x all over 1 divided by cosine of x minus sine of x over cosine of x. And what we want to recognize is that every single term has a cosine in the denominator. Since they all have a cosine in the denominator, what we can do is we can multiply everything by a cosine. So we're going to multiply by cosine on all of these terms, and they all disappear. So essentially this cosine of x cancels off every denominator. So the end result is I have 1 plus sine of x over 1 minus sine of x. Now, if we compare the given problem to what we have over here on the right, which is a good strategy to do, I notice that on the right-hand side, this numerator is equal to 1 plus sine of x quantity squared. So I'm going to multiply over here by another 1 plus sine of x over 1 plus sine of x and see what happens. In my numerator, I get 1 plus 2 sine x plus sine squared x, which is a match, telling me that I'm getting close. In my denominator, I have 1 minus sine squared x. Now, if we recall our Pythagorean identities, 1 minus sine squared x equals cosine squared of x. So we have made it. 1 plus 2 sine of x plus sine squared of x all over cosine squared of x. We got it. I think this deserves a double smiley. All right, that's it. Go ahead. Good luck on your homework. Homework is to finish worksheet 0.